Whenever you guys are ready, can you talk through what you put together?
Yeah, sure. So this is a drone where essentially we have a Pi Pico which controls sort of the motor outputs, and this runs like a PID controller. And so here we have it directly interfacing through 4 PWM channels, which goes to an electronic speed controller, which then controls the motors. And it's also interfacing with this IMU here. And there's a receiver actually tucked under the Pi Pico, which is communicating to the Pi Pico over UART using this controller.
Okay. Cool. And a little custom PCB here.
Yes, this was developed by another student.
Okay,
actually,
neat.
Chen.
Just a power distribution board.
Okay.
Yeah.
Neat.
Takes the battery voltage and converts it into
Okay.
usable 3.3 volts.
Cool. And let's see, whole thing's powered by this guy.
Yeah, powered by that with a safety switch.
There's a 4-cell lithium polymer battery. It's
Okay.
currently charged at 16 volts.
Neat. Awesome. And so you guys have been working on getting it to hover?
Yeah, PID control has been our main thing. So we implemented a few things to make that easier. First we did like an actual serial interface.
So you have the ability here to set.
Yeah, so it prints out all of our values. We can change the values. I'll change it to 11 for a second just to show that. All these values are saved, so if we power off the drone and power them back on, it will save that 11. Even if we flash a new program, it'll still save that as well.
Are you doing that by writing to the Pico flash memory?
Yes.
Okay.
Yeah, we're writing with a Pico flash.
Okay.
Other than that,
That's a cool idea. Yeah, neat.
I'll arm it.
Okay. Let me move this. Okay.
Did you power it on there?
Yeah, I did power it on.
Okay, so
So a slight issue is that so whenever you power it on, it calibrates the gyro at the current position.
Sure.
So
Okay.
I guess so. Now we're gonna calibrate it actually level, so it'll reach this target position. And this is the ESC, so the Pico calibrates the ESC through the full PWM range every time it
Gotcha.
starts up. Okay, so now we're ready to. Okay, now I'll remove this.
yeah.
So now if we give it a bit of throttle, it's more responsive then. So it's very responsive if you sort of push it here.
So it's showing good disturbance rejection.
Yes.
In all directions too, even
Yeah.
Cool. Okay. And you're mounted on a rig here that allows for this to rotate in any direction.
Yeah, and if it was stable enough, we could.
It can actually lift itself up. Okay. But prevents it from flying around the lab and into the walls and stuff.
Exactly.
Neat. Very cool.
And then we also implemented kind of a forward reset with the PID control, so that if we turn this off, it should be accumulating I error the whole time. You would expect, well, actually the behavior we got before we implemented this is if we arm right now, these motors would be at full throttle due to that error.
Yeah.
Which is the reason why it's covered in dirt right now. So that exactly happened. It just cooked up a bunch of dirt.
But now if I arm, it's
quickly kickbacks and returns back to level.
Cool. So your I term in your PID controller isn't just growing without bound.
Everything gets reset while it's disarmed, and then only while it's armed is any ability to run.
Neat. Okay. Really nice. And
And we do have throttle control and everything too. It's kind of unstable for the noise, but we could theoretically fully implement a controller.
I wish I had video of the before because it's remarkably stable compared to sort of the way that this existed at the beginning of this project. Yeah. Really nice. Anything else to mention?
It's kind of an interesting computing problem because it's sort of a 3-axis system, but as soon as you make some motors spin faster than others, that introduces some torque about the drone, which causes it to rotate. So you have to counteract that, and then that can kind of be a cycle that you have to really.
So it's hard to fully decouple.
Exactly.
Yeah, and then everything is based in noise as well. So it's when we increase throttle, it gets unstable.
Uh-huh.
Due to it being more noise. As soon as we get rid of noise, fire.
Interesting. And you're estimating angle using the IMU, correct?
Yeah.
And
it's
a complementary filter.
and
Okay.
low passes on all the acceleration things.
Okay. Okay. Really nice. I don't think I have any more questions. Anything else you'd like to mention? Okay, awesome. Thank you. That's a really cool demo. Looks really nice.